This is question 6 from the second CSAT sample paper. So here we're given a polynomial f of x, which is an x to the n plus an minus 1 x to the n minus 1, etc. all the way down to a naught. And we're asked, what does it imply if the limit as x goes to infinity of f of x over f of minus x is equal to minus 1? So you are asked to prove your answer. So it's not just giving an answer, it's giving a proof. So if you want to have a go at this question yourself, pause the video now. Okay, so first of all, what's the answer going to be before we try to prove it? Well, you should recognise that if we have an even polynomial, it goes something like this, like a u or an upside down u. So it goes, as we go to infinity in either direction, and bear in mind as x is going to infinity, minus x is going to minus infinity. So this looks like f as x goes to infinity, and this looks like f as x goes to minus infinity. So if we've got an even function, it does the same in both directions. It's either going positive in both directions or negative in both directions. So the ratio would be 1. And if we have an odd function, then it goes from negative to positive or positive to negative, in which case the ratio is minus 1. So it looks like we're going to have to get an odd function, but we have to show that. So to start, we need to be careful because this is a question about proof. It's worth noting that we're not told that these coefficients are non-zero. So, for instance, we don't know that the degree of f is n. It might be that some of these initial coefficients are 0 and the degree is actually n minus 2, for instance, and these two terms are both 0. So let's work in terms of the first non-zero coefficient of f. So let's say ak is the first non-zero coefficient. Just to be really careful, it's also worth pointing out, well, it's worth thinking, why does there have to be a first non-zero coefficient? Why can't they all be 0? And the reason is, we're assuming this and seeing what it implies, and if they're all 0, then f of x is just the 0 function, and then this limit doesn't exist because you can't divide by 0. So if all of the coefficients are 0, that limit is undefined. It's also worth pointing out that for polynomials, the limit is defined because there's only finitely many zeros, so after a while it can't be 0 anymore as we go too far to the right or too far to the left. So now let's start with this. Well, let's start with the left-hand side because it's the most complicated, and we'll try and rewrite it. The only thing we know about f is that it's in this form, although we'll start with ak because we said it's non-zero. And we'll try and expand on this left-hand side. So the limit as x goes to infinity of f of x over f of minus x is, well, I'll just plug in f of x on top, but starting from k, and f of minus x on the bottom, so I'm just putting minus x into each of these powers instead of x. And now you probably know that as x goes to infinity, the limit is just the ratio of these two terms. These terms don't matter anymore because these terms grow the fastest. But we have to, because this is a proof question, we have to show that rigorously. And the usual technique is to divide top and bottom by, in this case, x to the k, because then all these terms are going to be over some power of x, and we can say they're going to 0 as x goes to infinity, and therefore we can ignore them. It's also worth pointing out here, it's important now that we did start at k instead of n, because if I divided everything by x to the n, then actually all the terms would go to 0, because if the first term was actually 0, all the terms would go to 0, which wouldn't be good. So we'll just divide top and bottom by x to the k. What happens in each of these brackets? Well, for instance, in this one, the x's are all going to cancel, but we're still getting minus 1 to the k in here, minus 1 to the k plus 1 in here. So what we get on top is ak, then ak minus 1 over x, because I divided by x to the k, all the way down to a naught over x to the k. And on the bottom, the same thing, but with minus 1 to the k, minus 1 to the k minus 1, etc. And now we can say that as x goes to infinity, we just ignore all these terms with x's on the bottom. So the limit is just the ratio of the first two terms, which is ak and ak times minus 1 to the k. So obviously the ak's are going to cancel. We're basically getting minus 1 to the k, determining what the answer is. If k is even, we're going to get 1. If k is odd, we get minus 1. So we only get minus 1 here if k is odd. So we get minus 1 only if k is odd, and therefore if we have this limit equals minus 1, then we know that k is odd. And what is k? It's the first, k is the power in the first non-zero term. So we know k is odd where ak is the highest non-zero coefficient, is how I wrote it. Okay, so we're finished with that proof. That's the end of that question.